Hello everyone, in this video we are going to look at the method to solve simultaneous equation when one equation is quadratic, like the first one here, and the other one is linear, like the second one there. The method to do so is quite straightforward. You need to use the linear equation, so the second one here, to make one of the unknown the subject of the formula, and then use substitution. So this means that we first need to make x or y the subject here. We are going to do both and investigate how it changes the method so that you can clearly see what is best. If we decide to first make x the subject in here, we need to subtract 6 on both sides of this equation to get rid of this plus 6, leading us to 3y minus 6 is equal to x. So that's our first option. The second option is to make y the subject. We need to divide by 3 on both sides to get rid of this 3, and we end up with y is equal to a third of x plus 6, which multiplies out to a third of x plus 2. So from this point, some of you will notice that this might be easier to use, because I know some of you don't really like to use fractions like what we find here. We'll do both anyway and check that they both lead to the same result. So in the first one, we see that x here is equal to 3y minus 6. So in the first equation, we are going to substitute this x by this value. We get y squared is equal to twice x, which is 3y minus 6, plus 7. You see, I get exactly the same thing as I had before here, but this x has been changed for 3y minus 6. If we expand, we get that y squared is equal to 6y minus 12 plus 7. And if we put everything on the left-hand side, we get y squared minus 6y plus 5 equals to 0. So you see, basically, we end up with one quadratic equation in y here that we need to solve. To solve such an equation, remember, you only have two options, or 3 actually if you can completing the square, but which is not a really direct method. You can either factorize the quadratic or use the quadratic formula. Here, this expression can be easily factorized as y minus 5 brackets y minus 1 equals to 0. You can check that the product of minus 5 and minus 1 is plus 5, and the sum of minus 5 and minus 1 is minus 6. So this basically means that y is equal to 5 or y is equal to 1. We almost there. We have two possible values for y. We now need to get the corresponding values for x. We can use the fact as shown here that x is 3y minus 6. So y being 5 here implies that x is 3 times 5 minus 6. So it's 15 minus 6, it's 9. And if y is 1, 3 times 1 minus 6 is minus 3. So x would be minus 3. So here are our two sets of solution for these simultaneous equations. Let's now see what happens if we use this substitution instead. So if we change y in this equation to rewrite it as the third of x plus 2. We get a third of x plus 2 squared is equal to 2x plus 7. You can see that here we've substituted y. We knew that y was a third of x plus 2. So this is what we've written here. If we expand the square on the left-hand side, we get a ninth of x squared plus 4/3 of x plus 4 is equal to 2x plus 7. To make things slightly easier for us, let's multiply by 9 on both sides to get rid of the denominator. So keep in mind that here the whole left-hand side needs to be multiplied by 9, and same thing on the right-hand side. So we get x squared. If you multiply the 9 over the 4 thirds here, the 3 is going to cross out one of the 3 in the 9, so you end up with 12x, and 9 times 4 is 36. And this has to be equal to 18x plus 7 times 9, which is 63. Let's put everything on the left-hand side. We get x squared minus 6x minus 27 equals to 0. Here again, you can factorize this expression as x minus 9 times x plus 3 is 0. And check that minus 9 times plus 3 is a minus 27, and minus 9 plus positive 3 is a minus 6. So we end up with two solutions. X is minus 3 from this one, or x is positive 9 from that one. You can notice that it's exactly the two values for x that we have found with the first substitution. So from this x is 9, let's work out the y. A third of x is going to be 3. 3 plus 2 is going to be 5. So the corresponding value of y here is 5, which completely matches here the first solution we had. If we then substitute x for minus 3 to get the second set of solution, a third of minus 3 is going to be minus 1, plus 2 is going to be 1. So this x is minus 3 implies that y is 1, which is, again, the same set of solution as this one. So to summarize a little bit what we did, you see that the first step you need to complete is make one of the unknown subjects in the linear equation. You see, it doesn't really matter which one you use, depending on your feeling about fraction and things like this. One of these two options may be more convenient. Once you've done this, you end up with a quadratic in one unknown, either here or there, that you need to solve by factorizing or by applying the quadratic formula. You find two possible values for your unknown, and then you need to work out the corresponding values for the second unknown. I hope this helps you getting clearer ideas about this topic, and see you next time.